Have you ever pondered how our brain, a seemingly rigid structure, can adapt and change throughout our lives? It's a question that has intrigued scientists and laymen alike for centuries. This enigma starts to unravel when we delve into the fascinating world of neuroplasticity, a concept that illuminates our understanding of the brain's remarkable ability to reorganize and grow. It's a journey of discovering how our brain can rewire and morph in response to new experiences, learning, and even injury. The answer to this riddle lies in the phenomenon we call neuroplasticity. Our journey begins in the 18th century with Italian anatomist Michele Vincenzo Malacarne. Malacarne was a pioneer in the field of neuroscience, conducting groundbreaking experiments on neuroplasticity as early as 1793. His approach was rather unique for its time, employing a method of paired animal training followed by anatomical dissection. In these experiments, Malacarne would pair two animals, train one extensively for a number of years, while the other remained untrained. Following this rigorous training period, he would then dissect both animals for comparative analysis. What he discovered was nothing short of remarkable. The cerebellums of the trained animals were noticeably larger than those of their untrained counterparts. This suggested that the brain, much like a muscle, could be developed and strengthened with training and exercise. Malacarne's findings were a significant leap forward in our understanding of the brain. He had provided the first tangible evidence that the brain's structure could change and adapt in response to its environment and experiences. His work laid the groundwork for the concept of neuroplasticity, the idea that our brains are malleable and capable of change, growth, and reorganization. Unfortunately, despite the groundbreaking nature of these findings, they were not widely recognized or understood during Malacarne's lifetime. His work on neuroplasticity was largely forgotten, overlooked in the annals of scientific history. The scientific community at the time was not ready to embrace the idea that the brain, once thought to be a static and unchanging organ, could be so flexible and adaptable. So the idea of neuroplasticity, the ability of the brain to change and adapt, lay dormant for nearly a century. The world would have to wait until the late 19th century for this concept to be rediscovered and appreciated. Then, the idea of brain's plasticity was largely overlooked until the late 19th century. The story of neuroplasticity was just beginning, and its rediscovery would revolutionize our understanding of the brain and its incredible capacity for change. Fast forward to 1890, when William James breathed new life into the concept of neuroplasticity. In an era when the brain was largely considered a static, unchanging organ, James challenged the status quo. In his seminal work, The Principles of Psychology, he introduced the term plasticity to describe behavior. He used it to paint a picture of a structure that was at once supple and resilient, weak enough to yield to an influence, but strong enough not to yield all at once. This was a radical shift in thinking. The brain was not just a lump of grey matter, fixed and immutable. Instead, James suggested it was a dynamic organ, capable of changing and adapting. But the idea was far ahead of its time, and the scientific community was not ready to accept it. The dominant belief remained that the brain's structure was fixed throughout adulthood. This was a time when the concept of neuroplasticity was still in its infancy, an unproven hypothesis in a field dominated by hard facts and empirical evidence. The brain was viewed as a machine, its parts set in place, its functions determined at birth. Yet, despite the prevailing skepticism, the seed of the idea had been planted. William James had stoked the fires of curiosity, and the concept of neuroplasticity began to smolder in the collective consciousness of the scientific community. His work sparked a series of investigations, experiments, and debates that would continue for decades. Neuroscientists, psychologists, and philosophers all grappled with the implications of a brain that could change and adapt. However, it would take several more years and the relentless pursuit of truth by a few dedicated scientists before the concept of neuroplasticity would be widely accepted. It was a slow process, a gradual shift in thinking that would revolutionize our understanding of the brain and its incredible capacity for change. The concept of neuroplasticity was yet to gain widespread acceptance. Yet, the stage had been set, and the curtain was about to rise on a new era in neuroscience. Enter Santiago Ramon y Cajal, the father of neuroscience, who used the term neuronal plasticity in the early 1900s. This Spanish histologist and pathologist was instrumental in shaping our understanding of the brain's structure. He was a true trailblazer, challenging the common belief of his time that the brain was a non-renewable organ. Cajal was a meticulous observer and a detailed illustrator. He spent countless hours peering down the microscope, sketching what he saw. His detailed drawings of the brain's structure were revolutionary. He demonstrated that the brain was not a continuous network, as was widely believed, but a complex network of individual neurons. This groundbreaking idea is known as the neuron doctrine. The neuron doctrine established the neuron as the basic unit of the nervous system, a concept that is fundamental to our understanding of the brain today. Cajal's work on this doctrine laid the groundwork for the concept of neuroplasticity. The term plasticity was used by Cajal to describe non-pathological changes in the structure of adult brains. He found that the brain's structure could change and adapt, which was a radical departure from the prevailing thought of the time. His work showed that the brain was not a static organ, but a dynamic one, capable of reshaping itself based on experiences and stimuli. Cajal's use of the term plasticity extended to his work on degeneration and regeneration in the central nervous system after a person had reached adulthood. This was a significant shift in perspective, as many of his contemporaries used the term plasticity only to explain the regenerative capacity of the peripheral nervous system. Cajal's work stirred a controversial discussion among neuroscientists of his time. His ideas were revolutionary, challenging the status quo. But as we know now, his contributions were fundamental to the field of neuroscience. His work on neuronal plasticity gave rise to a new understanding of the brain, one that acknowledged its capacity for change and adaptation, even into adulthood. His insights forever changed the way we think about the brain and its incredible capacity for change. It wasn't until the latter half of the 20th century that the concept of neuroplasticity gained widespread acceptance. This was a revolutionary shift in the world of neuroscience, shaking the long-held belief that the brain's structure and function were immutable past childhood. In this modern era, the scientific community has come to understand that the brain is not static, but rather dynamic and constantly changing. This shift in belief was not just a minor adjustment, but a seismic shift that rocked the very foundation of neuroscience. Neuroscientists now acknowledge that many aspects of the brain can indeed alter or are plastic, even through adulthood. This alteration is not just a small tweak here and there, but can involve significant changes. It encompasses everything from individual neuron pathways, making new connections, to systematic adjustments like cortical remapping or neural oscillation. But it doesn't stop there. Neuroplasticity isn't just about the brain's ability to change. It's about the brain's ability to adapt and improve. It's about the brain's ability to learn and grow. This is where the concept of activity-dependent plasticity comes into play. Activity-dependent plasticity refers to the idea that our experiences and actions can shape our brains. The activities we engage in, the skills we learn, the memories we form, all of these can influence the structure and function of our brains. This has significant implications for healthy development, learning, memory, and recovery from brain damage. Imagine a brain that can adapt and improve with experience. A brain that can learn from mistakes and grow stronger with each challenge. A brain that can recover from damage and find new ways to function. That's the power of neuroplasticity. In essence, neuroplasticity has redefined our understanding of the brain. It has opened up new possibilities for research and treatment, and has given us a new perspective on the incredible adaptability and resilience of the human brain. Today, neuroplasticity is a well-established concept in neuroscience. It's a testament to our ever-evolving understanding of the brain, and a beacon of hope for those seeking to overcome neurological challenges. So what is neuroplasticity and why does it matter? At its core, neuroplasticity, also known as neural or brain plasticity, is the brain's remarkable ability to change through growth and reorganization. Imagine the brain as a bustling city with its neural pathways acting like roads. Just as a city grows, adapts and changes, so too does our brain. It's the process of the brain rewiring itself, creating new connections, and even making systematic adjustments such as cortical remapping or neural oscillation. But what does this mean for us? Well, neuroplasticity has profound implications in numerous aspects of our lives. It's the mechanism behind learning a new skill, acquiring new knowledge, adapting to environmental influences, and even recovering from psychological stress. It's the reason why practice makes perfect, as the brain strengthens the neural connections involved in performing a task each time it is repeated. Moreover, neuroplasticity plays an essential role in recovery from brain damage. It allows the brain to compensate for injury by reorganizing itself, creating new pathways to bypass damaged areas. Contrary to previous beliefs that the brain's ability to change was limited to childhood, we now know that our brains remain plastic even into adulthood. Though it's true that a developing brain exhibits a higher degree of plasticity, the adult brain is far from a static entity. In essence, neuroplasticity is the key to understanding how our brains learn, adapt, and recover, thus unraveling the complex workings of our minds.